Hi, today we are going to derive the Schrodinger wave equation. First of all, we will be doing the time dependent wave equation. For that, we need to write a general wave equation. Any equation, be an electromagnetic wave equation or a sound wave, can be written in the following using this following second degree differential equation. In this differential equation, psi represents a wave function. It can be E for electromagnetic wave, V is the velocity of the wave, X and T are the time and space variables. This is the one-dimensional case. Okay, so here we have, if I have this equation, a second degree differential equation, for that we have a solution. A solution to this wave can be written as this: psi x comma t is equal to a constant e to the power minus I omega. Omega is 2 pi nu, nu is the frequency, and v is again the velocity. So using this here, if I just put in that a few things like omega is equal to 2 pi nu, e is equal to h nu, and also v is equal to nu lambda, where nu is and lambda are frequency and wavelengths. Lambda is equal to h by p. I can get, if I plug in all these terms here in this equation, I will just, after a few algebraic expressions, I will get equation number 2. So here now we have an equation number 2 is also a solution of equation number 1, which is the time dependent wave equation. So equation number 2 is basically telling you what will be the wave function of the wave, provided wave function of the particle, provided we know E as well as P here, and also of course the constant. So here now what we do is, if we are talking about a particle, it will have an energy. Total energy is equal to p square by 2m, which is the kinetic energy, p is the momentum, plus v, v is the potential energy. So if I just write E is equal to p square by 2m plus v, and I can easily multiply this equation number 3 by a complex function which is psi, both sides. It is just a complex quantity. So I get an equation number 3. All this will lead us to the Schrodinger time dependent wave equation. So then what I do is, here from equation number 2, I can take out the energy variable outside, energy value outside, by just differentiating left and this whole equation by once by t. So if I do this differentiation, minus I by h cross, E comes outside, and this e to the power this, it remains like the same. So here I can write this as the following: del psi by del t is equal to minus I by h cross E psi, where this expression and this becomes psi. Okay. So now the same thing I can do if I want to take out the p momentum outside. I want to write it some here, I want to write the momentum. So if I just differentiate this with respect to x, minus I by h cross, if I differentiate it, minus p comes outside here, and the whole thing remains as it is. So this is nothing but the psi function. So del psi by del x is equal to ip by h cross psi x comma t. But if you notice in equation number 3, there is a p square. So I want a p square and not just a p. So what I'll do is, partly I will just differentiate it again. So if I differentiate it once again with respect to x, I will just do it here only instead of going back. ip by h cross del psi by del x. And del psi by del x is nothing but equation number 5. So I write down the value here, ip by h cross psi. And here, from here, del 2 psi by del x square is equal to minus p square by h cross square. I is minus 1 psi x comma t. So using what I need to do is taking a p square from here and taking a e psi from here, from equation 4. I put the values of p square and e psi in equation number 3. So if I do it in 1 or 2 steps, which I am skipping because of the time shortage, I will get this equation: h cross by I del psi by del t, h cross by 2m del 2 psi by del x square minus v psi. Please be very careful about the negative and positives. So this equation is the Schrodinger time dependent wave equation. Thank you.